Hello learners and welcome to a Natural Sciences lesson. So today we're going to be looking at series and parallel circuits. So before we start with the series and parallel circuits, did you know that the car headlights and street lamps, they use a parallel circuit? So in this lesson, you're going to be comparing a series circuit in comparison with a parallel circuit to see the differences between the two and also the similarities if there are any. But before we get to that point, there are certain goals that you and I are supposed to be having so that we can reach them by the end of the lesson. So by the end of this lesson, this is what I want you to be able to know. Number one, you need to be able to explain that the voltage is the same across each resistor that is connected in parallel in a circuit. Number two, you also need to be able to explain that the total current through the battery is equal to the sum of the currents through the resistors in parallel. Number three, you also need to be able to explain that the total current in the circuit increases as more resistors are added in parallel. And lastly, what you should be able to know by the end of the lesson is that you need to be able to explain why lighting systems in our homes is usually connected in parallel. So with all these goals that we need to achieve by the end of the lesson, we are going to take the main idea being now the series and the parallel circuit, and we're going to be starting by looking at we're going to now compare the two, the series circuit and also the parallel circuit. After that, we're going to be looking at the lighting systems that you are using in our homes so that we can then be able to achieve the goals that you said we need to achieve by the end of the lesson. Now, with this information, there's something that you already know about either the series circuit or the parallel circuit. So this is what you already know by now. That number one, an electric current is the movement of charge in a closed conducting circuit. We also know that an ammeter is a measuring device used to measure the electric current in the circuit. Remember, we can use the ammeter to measure the electric current in either the parallel circuit or also in a series circuit. We also know that as we add more resistors in series, the total resistance of the circuit is going to increase. So as more resistors are added in series, the total resistance of the entire circuit is increased. And lastly, we already know that if you add more resistors in series, the current in the whole circuit decreases. Now remember the relationship between current and resistance, that when one increases, the other one decreases, but only in this case we're talking about a series circuit. So with this information that we know, can we then be able to answer the information or these questions that are given to us? The first question says, what is meant by potential difference? What is meant by potential difference? And the second question is asking us, what instrument is used to measure current? So, to begin, potential difference is the difference in the amount of energy that charge carriers, in this case the electrons, have between 2 points in a circuit. So whenever we're measuring our potential difference, we're always going to be measuring it between 2 points in a circuit. And the next question is asking, what instrument is used to measure current? Now we need to remember that the potential difference that you're talking about, it is measured using a voltmeter, which therefore means that for us to measure current, we need a device called an ammeter. Now, we're also going to remember that this ammeter has low resistance, so therefore the connection of this ammeter, it matters. How we connect it in any circuit diagram that we have, it matters. However, with the potential difference, the voltmeter, the device that we are using, we should know that it has a high resistance, so therefore when it is connected to measure that energy between the 2 points, it must always be connected in parallel. Now here, they are asking, how should the instrument mentioned above be connected in a circuit? And we need to explain. The instrument mentioned above is our ammeter. So remember, we are saying that the ammeter has a low resistance, so therefore it matters how you connect it in a particular circuit diagram. So how should it be connected? It needs to be connected, it must be connected in series. It must be connected in series. Why must it be connected in series? Because it has a low resistance. It has a low resistance. So we always need to make sure that whenever we're trying to measure the current in any circuit diagram, be it's a parallel circuit or it's a series circuit, the ammeter must always be connected in series because of its low resistance. So with all these questions that we have answered, we now need to make sure that to better explain the main idea, you know which ways you're going to be using. So we're going to be using words such as electrons, a parallel circuit, an electric circuit, and also electric current to better explain the main idea. Remember, we are comparing, we're looking at the series circuit and also looking at a parallel circuit. Now, with all of these words that you are given here, we should know that electrons, that's now a negatively charged subatomic particle, and then the parallel circuit, that's now the type of circuit that provides more than one pathway for electric current to follow. And then number 3, electric circuit. That's now a conducting pathway for electricity. And then lastly, the electric current. That's now the movement of electrons through the conducting wires. So before we start with our first idea, our first concept, we're just going to go for a short break, and I will see you just after this.